All right, here is our last video for section 4.3. We're going to start talking about the zero product property here. You might have seen that in Algebra 1, but that's what's going to help us try to solve quadratic equations like these that you see here, right? The zero product property, so let's go and let me just highlight that really quick. That says if the product of two expressions is 0, so when I take one expression times another, and I know that they're equal to 0, then it's true that either one of the expressions is 0 or they're both 0, okay? Now let me go ahead and write that, let's say like in variables or in letters, symbolically. Let's say I took A times B, and this works for if A and B were numbers or if they were expressions, right? It would work the same way. If I know I get 0 when I multiply those two things, so if A times B is 0, then either A equals 0 or B equals 0. And I don't know, I'm gonna put a comma here. I don't know if that's grammatically correct, but I want you to see that it's either this, A equals 0 or B equals 0, or A is equal to B is equal to 0, right? So this is what the definition is saying in like symbolically. Either one of them is 0 or they're both 0, right? We can't have both of them be not 0. Like if I had 5 times 6, that's clearly not 30, right? 3 times 4, negative 2 times 11, 100 times 50 million. They both, either one of them is 0 or they're both 0 in order for this to be true, okay? So we can use this idea to help us solve these equations right here, all right? So x plus 5 times x plus 2 equals 0. I have two expressions that when I multiply them, I get 0. Well, I know it's not going to be this one right here because in order for the, sorry, I kind of misdrew the circle. In order for this one to be true, then both A and B have to be equal. But when I add 5 to a number, do I get the same thing as if I add 2 to that same number? Is 5 plus 1 the same thing as 2 plus 1? No, right? And that's never true. So it's not this one, it's this one right here. I take both of my expressions and set them equal to 0. So I get x plus 5 is equal to 0, or x plus 2 is equal to 0. And then we know how to solve for x here, right? And both of them, we just subtract over, right? So I get x is equal to negative 5, or x is equal to negative 2. Those are my two solutions to this equation. If I plug either one in for x, I'm going to get 0. Now remember, since these are both x, I can only plug one of these at a time. That's why I don't say and here. That's why that's not what we say here, because I can't plug negative 5 in this one and negative 2 in this one because it's only one x. I can only plug one number in at a time, all right? And then just to convince you, like if I plug in negative 5 here, negative 5 plus 5, that's 0. Negative 5 plus 2 is negative 3. 0 times negative 3 is 0. And then for the other one, if I plug in negative 2, negative 2 plus 5 is 3. Negative 2 plus 2 is 0. 3 times 0 is also 0. All right, so that's why it works. Now let's try the next one. The next one, we have one more step to do. We need to actually factor this one. So let's find our factor pairs. I know for 42, that's 1 and 42 is one of the pairs. We also have 2 and 21. And then we also have 3 and 14. Yep, just had to make sure. We know 4 doesn't work, and we know 5 doesn't work either. It's not divisible by 5. But then we know 6 works, and that's 6 times 7. And then that's all the pairs we can get. And then I know it has to add up to negative 1. Okay, we have a negative number that we're multiplying to. So remember, when we have a negative here, that means that they're different signs. One is positive, one is negative. But then this right here, the -1 here, tells me that the bigger one is negative, because if I subtract a big number from a small number, I get a negative. So all my bigger numbers have to be negative in this case. So -42, -21, -14, -7. Which one of these, when I add them together, is going to give me -1? You probably know, but if it's okay to check them all, right? We don't have to, not everybody has, I'm bad at mental math. So, sometimes I need a calculator. So if you need a calculator to do some of this, or if you need to write this down and do it by hand, then, so be it, right? You don't have to do this in your head. 1 minus 42, that's -41. 2 minus 21, that's -19. 3 minus 14, that's -11. And then 6 minus 7, that's -1. All right. Did we get what we wanted? Yep, we got the -1. Right? So we know our pair is 6 and -7. So this factors to x plus 6, x minus 7 equals to 0. Now we can go ahead and do what we did over here. I can say x plus 6 equals 0, x minus 7. Ooh, it's going to be cramped, equals 0. So then I subtract 6 here, and then add 7 over here. Sorry about that. I get x is equal to -6, or x is equal to 7. And those are my answers for this one. Okay, so notice how if I have this set up, normally if this was just x minus 42, I would add the 42 over. A lot of temptation is to add over 42 and like do some magic over here with x squared minus x, but that's not the case, right? We make sure that it's equal to 0, and then we factor the left-hand side, and then we can use zero product property like we did in part A. Okay, let's do 2 more examples of this kind of stuff. Okay, so on the left-hand side, we have t squared plus 4t plus 8 equals 4. Now careful, because our zero product property says that eventually it has to equal 0, right? It requires equals 0. So I need to make sure that there's an equals 0 over here first. Well, how do I get rid of that 4? I subtract it from both sides. So -4, -4. Let me go ahead and erase this because I didn't really need it. Okay, so then I end up with t squared plus 4t. 8 minus 4 is +4 equals 0. All right, so factors of 4, 1 plus 4, sorry, 1 and 4, and then 2 and 2. Both of them are positive. They have to add up to 4. We see that it's 2 and 2 give us 4. So then I have t plus 2, t plus 2 equals 0. So now I can use my zero product property. T plus 2 equals 0, or t plus 2 equals 0. T plus 2, so I subtract 2. Notice that it's the same thing, right? So we're really only going to get one unique answer. So we don't really have to write it out twice if you know it's just the same thing. So I get t is equal to -2. And that's my only answer for this one. Some of these you're only going to have one answer. All right. And now for one more. Okay. M plus 2 times m plus 1 equals 6. Now everybody's going to make the mistake here of saying, oh, okay, well then it's already factored. So m plus 2 equals 6. And m plus 1 equals 6. And I'm here to tell you that that is a big fat no-no, right? Evil. That's evil. That's kind of, I'm gonna erase it. I'm not even gonna leave it in red X because it's such an abomination, right? We wanna make sure that we're using our zero product property correctly. And remember, our zero product property says A times B equals 0. It says nothing about 6. It says nothing about -7. It says nothing about any other number on this side except for 0. So it has to be 0. And the reason why, and just so I'm not giving you another rule without explanation, right? The reason why is because how many different ways can you get 6 by multiplying two numbers? Well, with whole numbers, we only know of a few. We know 1 and 6 and 2 and 3. But there are so many other ways that can get 6 using fractions, using decimals, using square roots, using a lot of other things, right? And because of that, it makes it nearly impossible to just separate, to be able to figure this problem out without using our zero product property or the things you've learned already. Okay, so that's why it's important for you to get a 0 there on the right-hand side first before you apply zero product property. Well, how are we going to do that? Well, maybe, I can subtract the 6 over, but this is still kind of ugly. Let's multiply this left-hand side out first to get it in standard form, and then subtract our 6 over. So if we multiply that out, this becomes m squared plus 2m plus m plus 2, right? Hopefully you're okay with doing that multiplication now, right? Go watch the first few examples again if you're still a little uncomfortable with the multiplication. Equals 6. Clean this up a little bit. M squared plus 3m plus 2 equals 6. Now I can subtract the 6 over, and now this looks a lot like part C. M squared plus 3m. This is now minus 4 equals 0. All right, two numbers that multiply to -4 but add up to +3. Okay, I'm gonna skip ahead and tell you that those two numbers are +4 and -1, and I want you to make sure that you know why that's true. Okay, kind of if you need to do this work on the side, go ahead and do that. Or otherwise, maybe you're kind of already convinced, maybe you already knew ahead of time before I even told you it was 4 and -1, right? But make sure you know why that's true. And then, same as I have already been doing, set both of these factors equal to 0. I get m is -4 and m is +1 as my solutions. All right, not too terrible, okay? When we get to 4.4, it'll get a little bit more challenging, but that'll be for when we get to 4.4. Two more examples to kind of take it all home. The whole point of doing this stuff, the whole reason why we want to be able to solve these types of quadratic equations is for us to be able to find the x-intercepts of these quadratic functions, okay? Now you might be familiar with the intercept form that we talked about in 4.2, y is equal to a, x minus p, x minus q. That's why the x-intercepts are p and q, because of the idea that we can use this factoring idea to help us solve, okay? So let's make the connection between those two. Find the x-intercepts of the following quadratic functions. Well, when we find x-intercepts, when we take a quadratic function and set it equal to 0, we're getting the x-intercepts. And sometimes you're going to be seeing them called zeros or roots. Okay, so if you ever see those two words, know that it's the same thing as an x-intercept. Okay, so if I want to find the x-intercept of this first one, I want to take x squared minus x minus 12 and set it equal to 0. Okay, let's go ahead and factor two numbers that multiply to -12 but add up to -1. That's going to be x minus 4 because it's -4 and +3. Okay, now this is our intercept form. This is our x minus p, x minus q. This is how we can go from standard form to intercept form by factoring, right? To go from standard form to intercept form, we factor. Now we can't always factor, but when we can, that's how we get there, all right? And now we know why p and q are our x-intercepts, because we take x minus 4, set it equal to 0, and x plus 3, sorry, had a brain fart, x plus 3 and set it equal to 0. I get x is 4 and x is -3, right? So those are our x-intercepts. It's 4, 0 and -3, 0. All right, final example. If I want to find the x-intercepts of this, set it equal to 0. Right? And when we set things equal to 0, when we set a function equal to 0, that means we're taking y or f of x and we're saying, let's substitute in 0, right? That's how we find x-intercepts. Okay, how do we factor this one? Two numbers that multiply to 36, but add up to -12, that's gonna be -6 and -6, right? Notice that it's the same thing, so I'm just gonna have to do it once. X minus 6 equals 0. Our x-intercept is 6, 0. All right, hopefully that sounds okay. Rewatch any part of this if you need to, and I'll see you in the next one.